discussing the synchronous generator excitation systems. The topics to be covered today are excitation system for synchronous machines, DC exciters, static excitation, and brushless excitation. So what are the different excitation systems for the synchronous machines? Since the field winding is on the rotor, it is necessary to connect the DC source to the field using special arrangements. In small size synchronous machines, the field winding is excited from a separate DC source through slip ring and brush arrangement. For DC supply, the two slip rings made up of copper are installed on the shaft of the machine. In large machines, various schemes are employed to supply DC excitation to the field winding as DC exciters, static excitation, and brushless excitation. So one by one we will be discussing all these three types of excitations. The first one is the DC exciter. Now as you can see in the figure, we have got the main alternator, and to the alternator of the shaft, the two extra machines are being coupled to the same shaft, that is the main exciter and the pilot exciter. The main exciter generated voltage is being controlled by a rheostat, and the output of the main exciter is being fed on the slip rings of the field winding arrangement of the alternator. The pilot exciter serves the purpose of the field control of the main exciter. So what does a DC exciter consist of? In this method, three machines, namely pilot exciter, main exciter, and the main three-phase alternator are mechanically coupled and are therefore driven by the same shaft. The pilot exciter is a DC shunt generator feeding the field winding of a main exciter. The main exciter is a separately excited DC generator which provides the necessary current to the field winding of the main alternator through brushes and slip rings. This conventional method of excitation suffers from cooling and maintenance problems associated with the slip rings, brushes, and commutator with the higher rating of the alternators. The modern excitation system have been developed by eliminating the sliding contacts and the brushes. That is, this has left up to the static and brushless excitation systems, eliminating the slip ring and brush arrangement. So the static excitation, over here you can see the arrangement of it. There's static excitation, the alternator is there and its field is being supplied through a slip ring and brush arrangement, and it has been at the starting of the alternator, the field winding is given a supply through the battery bank, and once the motor starts, the battery bank is disconnected and the alternator AC voltage itself is stepped down and regulated through the firing angle of the thyristors, and the rectified output is being fed to the field winding. Once the alternator starts the generation, the generated voltage is fed through the CTPT to a step-down transformer, and from the step-down transformer, it is being fed to the three-phase bridge rectifier, and the firing angle is being controlled by the regulator, and the output of the bridge rectifier is being fed to the field winding of the main alternator. So the excitation power for the main alternator field is drawn from the output terminals of the main three-phase alternator itself. A three-phase transformer T1 steps down the alternator voltage to the desired value. This three-phase voltage is fed to a three-phase full-wave bridge rectifier using thyristors. The firing angle of these thyristors is controlled by means of a regulator which picks up the signal from the alternator terminals through which potential transformer and current transformer is also connected. The controlled DC power output from thyristor unit is delivered to the field winding of the main alternator through the brushes and slip ring arrangement. While initiating the process of static excitation, first of all, the field winding is switched on to the battery bank to establish the field current in the alternator. The alternator speed is adjusted to the rated speed. When the output voltage from the alternator is built up sufficiently, the alternator field windings is disconnected from battery bank and is switched on to the thyristor bridge output. Sufficient protection devices are installed in the static excitation scheme for any possible fault in the excitation system. What are the advantages of the DC excitation? This static excitation has got the advantage in its response time, that is very small, about 20 milliseconds. It eliminates the exciter winding loss and commutator bearing and winding for the maintenance purpose. As the excitation energy is taken from the alternator terminal itself, the excitation voltage is directly proportional to the alternator's speed. This improves the overall performance of the system. Now next comes the brushless excitation. Now over here, brushless excitation means we won't have the slip ring and brush arrangement over here, and the generator voltage itself will be stepped down through CTPT, fed to the regulator, and from regulator it will be the three-phase rectifier which is being controlled, and there will be a permanent magnet generator which is coupled to the same shaft, and the permanent magnet generator voltage is being fed to the thyristor bridge. The brushless excitation system consists of an alternator, rectifier, main exciter and a pilot exciter, that is permanent magnet generator, which will be shortly called as PMG. Both the main exciter and the pilot exciter are driven directly from the main shaft. The main exciter has a stationary field and a rotating armature which is directly connected through the silicon rectifiers to the main alternator field. Thus the slip ring and brushes are eliminated. The main exciter field is fed from a shaft driven PMG having rotating permanent magnets attached to the shaft and a stationary three-phase armature. The AC output of the permanent magnet generator is rectified by three-phase full-wave phase control thyristor bridges. The thyristor assembly is usually housed in the removable drawers which can be taken out easily for the repair purpose. The thyristor bridges are controlled by a set of dual firing circuits operating in parallel. The base excitation is controlled by an input setting to the thyristor gating circuits. This control signal is derived from the permanent magnet generator via a regulator DC supply which also serves the regulator logic circuitry. The regulator controls excitation by supplying a buck boost control signal which adds algebraically to the base setting. The regulator elements also comprise of solid state circuits. The excitation system has a short time constant and a response time of less than 0.1 seconds. So today we have discussed about the excitation system required for the synchronous machine. The DC exciter disadvantage is 3 additional motors are being coupled to the main excitation system, plus there is a brush and slip ring arrangement which needs constant maintenance. Similarly, for the static excitation, the remaining things are okay. We have removed the extra machines, but static excitation suffers from the slip ring and brush arrangement which requires regular maintenance. So our best system is the brushless excitation system where the slip ring brush arrangement has been removed and the supply is given through the thyristor control bridge rectifiers, plus it is given through the permanent magnet generator which is being controlled by the thyristor bridge circuitry. Thank you.